For months, the world had been counting down to October 3rd, the date NASA itself had marked as the day of revelation. It was supposed to be the moment the mystery of 3I Atlas, the strange interstellar visitor that had gripped every major observatory on Earth, would finally be solved. In countless press briefings and interviews, NASA officials were pressed with the same question. Was it a comet or something far more advanced? Each time they gave the same measured response. Once high-resolution images from Mars came through, captured during the object's closest pass, just 29 million kilometers above the planet's surface, they would be able to confirm its true nature. That promise became a global countdown. Everyone waited for that single image, that one revelation that would tell humanity what exactly had entered our solar system. And then finally, October 3rd came. But when journalists, scientists, and amateur astronomers tried to check NASA's official pages, they didn't find the long-awaited data. Instead, every major NASA site covering 3I Atlas displayed the same bland message: under maintenance, unable to update. At the time of the Mars flyby, 3I Atlas was positioned on the far side of the Sun, directly opposite from Earth. That meant no telescope on or near Earth could capture it in real time. The Sun's glare made it completely invisible. The only eyes on it were those orbiting Mars, and those spacecraft belonged to NASA and ESA. And yet those eyes in the dark stayed silent. So what had the Mars orbiters actually captured that was so terrifying it couldn't be released? Inside the scientific community, quiet panic began to spread. Some whispered that what NASA had seen was simply too horrifying to reveal, that releasing it might spark global chaos and mass panic. Others suspected something more calculated, that the so-called shutdown wasn't a coincidence at all, but a deliberate move to delay disclosure until officials decided how to explain what they found. But no one really knew what was happening inside NASA, where the 3I Atlas data had gone, or what those missing Mars images might have shown. While the public stared at empty NASA pages, one astrophysicist broke the silence. Drew Doss, a little-known but meticulous researcher who had been tracking 3I Atlas for months, posted a 9-minute clip on Twitter late on October 3rd. The footage, stitched together from Perseverance rover images, showed a faint streak crossing the Martian sky. Frame after frame, the streak refused to match the predicted star motion. When Doss overlaid NASA's own published ephemeris for 3I Atlas onto the images, it didn't line up. The object wasn't where NASA had said it would be. It wasn't moving on the path they predicted, but using publicly accessible collaboration software, Doss found its chemical fingerprint. The mix of ionized gases, the unusual nickel without iron spikes, and the odd plasma glow were exactly what had been measured from 3I Atlas for months. In other words, it wasn't another object, it was still 3I Atlas. Only now it was off course. That was the real shock, because objects can fragment, brighten, or shed tails. They can even break up. But their orbit, their path through space, is supposed to be one thing that doesn't change unless a huge external force acts on it. Yet here was 3I Atlas, traveling on a different trajectory than every published prediction. So how was it even possible for its course to change like that? Until October 2nd, NASA's official track was clear and stable. 3I Atlas would pass Mars on the 3rd at about 0.2 astronomical units, roughly 30 million kilometers away, skim past Jupiter later in the month, then loop close to the Sun between October 29th and 30th before heading back out into deep space. Every calculation agreed, zero risk to Earth. But when Doss's clip and telemetry data from the Perseverance rover and ESA's Trace Gas Orbiter were reviewed, analysts noticed something that couldn't be dismissed, a subtle but undeniable anomaly. The object wasn't where it was supposed to be. It had drifted inward, only a few arc-seconds off course. But the tiny deviation meant something alarming. 3I Atlas had moved nearly 2 million kilometers closer to the Sun than predicted. At first, scientists assumed it was an error, maybe a timing glitch, maybe the result of image calibration, but then China's Tianwen-1 and the European Mars Express returned the same readings. The shift was real. Then what exactly happened? Physicist MICHIO Kaku described it as a perfect example of how tiny mistakes in the cosmic dance can become catastrophic. His simplest explanation involved gravitational mechanics. As 3I Atlas flew past Mars, it didn't follow the precise altitude scientists expected. It passed lower, perhaps only a few hundred kilometers, dipping deeper into the planet's gravitational well. The small difference acted like a slingshot, stealing just enough of its forward momentum to pull it slightly inward toward the Sun. But even Kaku admitted that alone couldn't account for the entire deviation. Around the same moment, ESA's trace gas orbiter recorded an unexpected spike in plasma near the object, a clear sign that part of its surface had vented violently. In space, when superheated gas bursts from one side of a body, it creates thrust, a natural engine effect that pushes it in the opposite direction. That combination, the gravitational tug from Mars and the thrust from the venting, changed 3I Atlas's speed by just 4.66 meters per second, less than the pace of a person walking down the street. But in the vacuum of space, where trajectories stretch across millions of kilometers, that's all it takes to rewrite the future. That micro-nudge sent 3I Atlas drifting off its predicted course, not away from the Sun, but toward it. The new orbit was tighter, faster, and dangerously unstable. Instead of leaving the solar system as planned, updated simulations now showed the object's path slicing directly through the exact plane of Earth's orbit. It was a shift so small no telescope on Earth would have noticed it if Mars's spacecraft hadn't been watching. Yet that minor cosmic slip may have just turned an interstellar visitor into a potential planetary threat. Simulations, run by MIT researchers and independent observatories, showed something that shouldn't even exist in probability, a 45% chance that during its next pass, between November 15th and 27th, 2025, 3I Atlas would cross directly through Earth's orbital plane. In many models, it missed us barely. Some showed it skimming our upper atmosphere before shooting back into space. But in others, it didn't escape at all. It plunged straight in. Even without a direct collision, the consequences could be catastrophic. The object's immense gravitational and electromagnetic field could disrupt Earth's magnetosphere, distort atmospheric conditions, and throw global weather into chaos. Power grids could fail. Satellites could lose orientation. Communication systems might collapse. But if impact occurred, a 5-kilometer-wide interstellar object weighing nearly 33 billion tons, traveling at 68 kilometers per second, it would release more energy than 50,000 Hiroshima bombs in an instant. For perspective, the asteroid that wiped out the dinosaurs, the Chicxulub impactor, was only twice its size and traveling slower. Even a glancing hit would be enough to ignite the atmosphere, flatten continents, and plunge the planet into a years-long winter. An ocean impact would send hundreds of meters-high waves racing across entire coastlines. Civilization as we know it wouldn't end in fire. It would end in silence, dust, and darkness. And that's why the silence after October 3rd was so haunting. For months, Harvard astrophysicist Avi Loeb had been quietly warning NASA to treat 3I Atlas as more than a normal comet, to monitor it with the same seriousness as an incoming asteroid. Each time the agency responded the same way. It's a natural object, its trajectory is safe. There is no risk to Earth. But now the numbers didn't lie. Something had changed, and no one was telling the world just how much. At the very moment when the public needed answers, NASA announced that due to low funding, key operations and missions were being temporarily suspended. But what no one could explain was why the trajectory had changed so suddenly. Avi Loeb told a podcast the next morning that the new numbers were alarming not just because of the proximity to Earth, but because of what they said about the object's nature. It had endured the Sun's most powerful coronal mass ejection without shedding a tail. It had maintained a mass estimated at 33 billion tons, with a nuclear-like energy output approaching 10 gigawatts at its core. Its spectrum showed nickel with no iron, a composition only found in industrial-scale production, a sign of advanced technology. It had accelerated from 60 kilometers to 68 as it approached the Sun, and now apparently it had altered course. The possibility Loeb hinted at was darker. If 3I Atlas isn't natural, its behavior might not be random. That would also explain the uncanny alignment with the solar system's plane, its near-perfect timing with the WOW signal direction, and its ability to absorb rather than shed energy under solar assault. And anything that can change trajectory once can do it again, Loeb warned. Elon Musk later joined the discussion, saying during a live stream that 3I Atlas didn't look like a rock anymore. It looked like an advanced civilization's probe. Musk pointed out that a gravitational slingshot could alter an orbit slightly, but not with this level of timing and precision. The trajectory shift happened at the exact point where a controlled burn would produce the most efficient inward turn toward the sun, the kind of maneuver SpaceX engineers use for deep space navigation.